Hello, and welcome to a little video about the Unit 6 quiz review. Let's get started. Alright, for number 1 through 4, what we're going to do is we're going to match the statement and the postulate. Okay, on the first image, what I see is a line with some line segments. And I see 2 line segments marked. So let's see what statement that could be. It looks like the only one that talks about line segments is letter C. So statement C. Perfect. I'm going to cross it off. Well, let's think about the postulate that could be. Take a look at the 4 postulates. Which one talks about segments? That's right, the very last one, the second letter F, because I made a little oopsie, segment addition postulate. So I'm going to call this F2. Okay. Number 2. Here I see a couple of angles. It doesn't look like there's any specific measurement, but there's 2 angles that are marked. One angle is ZXY and the other one is WXZ. Let's see if I can find that anywhere. It looks like statement D is our answer. We have WXZ plus ZXY. That gives us this giant angle WXY. And WXY is this angle. Perfect. So our statement is letter D. Let's think about the postulate. What I did here in this statement is I added 2 angles. Which postulate do you think that is? Yep, letter E, angle addition postulate. Number 3, I once again see 2 angles marked. However, it looks like to me these 2 angles form a straight line. Straight lines are 180 degrees. When angles form together to create 180 degrees, they are called supplementary. Which statement do you think matches that? A or B? You should have thought letter A because it says GFH and KFH are supplementary, and those are the 2 angles that are marked. All right, we've got 2 postulates to pick from. We've got the linear pair postulate or the vertical angle postulate. Which one do you think is us having 2 angles that form a line? The linear pair postulate. I'm going to call it F1 because it's the first F we have. Now, of course, we only have 1 statement and 1 postulate left, but let's still take a look at the image. Now, in this image, we have 2 angles marked the same way. When we mark an angle the same way, that means they are congruent, they are equal, they have the same value. That is why I would choose statement B, that angle GFJ is congruent to HFK. They have the same value. We don't know what that value is, but based on the markings in the image, they are congruent. This is called the vertical angle postulate. Now, the best way for me to remember the vertical angle postulate personally is I imagine these 2 angles forming V's across from each other. Because despite the name of it, they're not always vertical. In English, when we think of vertical, we think up and down. Sometimes they're horizontal, like it is in this picture, or sometimes they're diagonal. Regardless, they are a vertical pair. Onwards we go. In number 5, let's find the measure of x for each angle. Oops, I zoomed in too much. Sometimes the tablet doesn't like when I do that. I'll be gentle. Alright, in number 5, it looks like I have 2 angles that form a straight line. That means this is a linear pair. Linear pairs form 180 degrees. 180 degree angle. Okay, so we have the measure of the angle on the left, 124, plus the measure of the angle on the right, x minus 3. Together, they form a straight line that gives us 180 degrees. Let's color code just a tiny bit. Got 124 and x minus 3 from here. And I got this 180 because it is a straight line. Okay, now let's solve it. Well, the very first thing we need to do here is combine some like terms. Do you see the like terms on the left side of this problem? Hopefully you notice that 124 and minus 3 are like terms. Let's combine them. 124 minus 3 is 121. So we have x plus 121 equals 180. Okay, what do you think we should do next? If you thought we should subtract 121 from both sides, you'd be correct. Let's do it. Minus 121, minus 121. On the left side, 121 minus 121 is 0. So we're left with x equals 180 minus 121 is 59. So x equals 59. Fantastic. Onwards we go. Oh, is that A? Is it man? Okay, let's go in alphabetical order. Let's do letter B. Now, letter B is very much the same idea as letter A, because we have two angles that form a straight line, so they're supplementary. We can add them and set them equal to 180. So if I add this angle plus this angle, I get 180. Let's do that. We got 7x minus 14 plus 2x plus 5 equals 180. You know me and my color coding. All right, let's do some combining of like terms. On the left side, I actually happen to see two pairs of like terms. Do you see them too? First, I hope you notice that we have two types of x's. We've got 7x and positive 2x. 7 plus 2 is 9, so we get 9x. Next, let's combine the other like terms. The other like terms are our regular or constants, our regular numbers without any x's or y's, just constants. We got negative 14 and positive 5. Negative 14 plus 5 is negative 9. And still equals 180. Great. What should our next step be? If you thought that our next step should be adding 9 to both sides, you'd be correct. We're adding 9 to undo that plus 9. That minus 9. So negative 9 plus 9 is 0. So all we've got remaining on the left is 9x. And on the right side, 180 plus 9 is 189. We got one last step to do. What do you think we should do? Let's divide both sides by 9. So we get that x equals 21. Fantastic. Onwards to letter C, which is up here. If it loads, there we go. All right. Oh, in letter C, I see two angles across from each other. When we have two angles across from each other like this, that means that they are vertical angles because these two lines are crossing and they're directly across from each other. What that gives us is two equivalent angles, which means we can take the left side and set it equal to the right side. Let's do that. We got 85 equals x plus 25. Right? Let's draw a line down the middle and start solving. Oh, this is a nice one. It's just a one-step problem. What do you think we should do to both sides? If you thought we should subtract 25, you'd be right, because we're undoing the plus 25. So, on the right side, we just have x, and on the left, 80 minus 25 is 60. And finally, let's do letter D. Once again, we got two lines crossing each other, forming a pair of angles that is across from each other. Oh, did I zoom out again? Okay. Well, I zoomed in too much and then I zoomed out. There we go. Back we go to letter D. So, just like in letter C, we can set these equal to each other. What? I don't know why it's doing that. I'm just gonna gently, okay. I'm not gonna zoom in any further. There we go. We're gonna set the right side equal to the left side. Okay, so we got 2x plus 15 equals x plus 30. Alright, what do you think we should do first? Now there's 4 options, honestly, of what we could do first. I'll do what I like to do first. No, that's because I'm making a video. But think about what you could do first, possibly. Alright, the way I'm going to do it is by starting to subtract x from both sides. The reason I'd like to do that is because I need to get my x's on one side and my constants on the other. So I'm going to subtract x from the right and from the left. On the left side, 2x minus x leaves me with x. The plus 15 stays. And on the right side, 30 just stays 30 because the x's cancel each other out. Alright, we got one last step. What do you think that is? If you thought we should subtract 15 from both sides, you're right. Let's do it. And we get that x equals positive 15. Alright. Now, you could have started this problem by subtracting 15, subtracting 30, subtracting 2x. Regardless, you would have ended up with the same answer as me. Alright, onwards we go. Once it loads, there we go. Next, let's write the congruent statements that are represented by the markers in each diagram. So what we're going to do is we're going to match each angle and side from each triangle and write down the congruency statements. Alright, let's do this. Let's begin with the sides. In number 5, do you see the side on the left triangle and on the right triangle? Whoops. That is marked with 1 tick mark. Hopefully you see that on the page in front of you while I'm scrolling. Alright, 1 tick mark. Now, although the whole point of marking angles and sides with ticks and arches is to avoid having to do color coding, I'm still going to do color coding because that's who I am. So, I'm going to color the sides that we have marked. I've got this side marked and this one. On the left triangle, that side is called AE. You could have also called it EA, as long as it has both of those letters. On the right triangle, the side that holds my tick mark is side CD, or you could have called it DC. When you're writing these, don't forget to use the little top, the little hat on top. Okay. Next, we have our angles. I see 2 types of angles marked. There's one with a single arch, and then there's another with a box. Now, the difference is, well, the one that has a box is it tells us that that angle is exactly 90 degrees. The ones with arches, all they're telling us is, hey, these angles match, but we don't know what their measurements are. So, hi Hazel. My dog is trying to get in my lap. Not right now. Let me finish the video. Okay? You're a good girl. Okay. Alright. So, yes, thank you for your paw. Good girl. Alright. So, we have 2 ways of naming these angles. We can use 3 letters, or in this case, we can use 1 letter, as long as we make sure to use the vertex. Let's start with the box. So that means this angle and this angle. Now I can call it angle A on the left and angle C on the right. We could also use 3 letters to name it. And I know I have some students that prefer to do it that way, so let's go over it. If we use 3 letters, we want to make sure that the angle that we're referencing is in the middle. It's the vertex. So angle A we could also call angle BAE. On the right triangle, we can do the same thing with angle C, as long as we're careful and we make sure that C is in the middle. We can call this angle BCD. Either way would be correct. Let's do the same thing with the angle with one arch on it. We have one right here, angle E, and an angle D. So just like before, because there's no other angle E or angle D possible, and same with angle A or angle C, we can use just one letter. So we've got angle E congruent to angle D. But if we want to stick to using 3 letters, which is always going to be correct, we're going to make sure to write this angle and keep E in the middle. So I can call this angle AEB. You could have called it also BEA. On the other side, I can call this angle CDB, or we could have called it BDC, as long as the letter D was in the middle. Let's do the same thing with number 6. All right, let's start off with the sides. Do you see the side that has just one tick mark? We've got the side on the left, LJ, or you could have called it JL, and on the right, we got ST or TS. Now let's do the one with the double tick marks. Do you see the 2 lines that have 2 tick marks on them? On the left triangle, I'll call it LK or KL. And on the right triangle, I'll call it SK or KS. Either one of those would be correct. Lastly, we have our angles. Just like in the previous problem, we have a little box here. The boxes just mean that this angle in particular is 90 degrees. And just like in the previous problem, we could either use 1 letter or 2 or 3 letters to represent this. Now, when would I have to use 3 letters? Well, if you take a look at K, for example, if I had the side of K like right here marked and right here marked, I'd need 3 letters to be exact about which angle K I'm talking about. Right, well, let's write down the congruency statement. I got angle J, which I could also call LJK. And I have angle T, which I could also call STK. You don't need to do both ways on the quiz or the test. You need to pick just one way. If you have a hard time remembering which way we use when, always use the 3 letters. Those will always be correct. Otherwise, if you can remember that we are allowed to use just one letter, the letter of the vertex of the angle, when there's only one possibility for that angle, then do that. All right, onwards we go to number 7. Number 7 and number 8 are those unique situations where we absolutely have to use 3 letters for some certain angles. Let's do it. First, in number 7, let's start with the sides. Hopefully you see that there is 2 sides marked with 2 tick marks. Let's write those down. I've got QR on the top and SR on the bottom. Do you see the sides that are marked with 3 tick marks? We've got PR on the top triangle and TR on the bottom triangle. Lastly, I hope you can see the pair of vertical angles that are marked with a single arch. Now both of these angles have R as its vertex. So we absolutely have to use 3 letters. Because if we just say angle R, I don't know which one we're talking about. So, for the top triangle, I've got PRQ. Or, of course, QRP would work too. Excuse me. On the bottom triangle, we need to make sure that R remains in the middle at the vertex. That's the vertex. I'm going to call this angle TRS. You could have called it SRT as well. Now let's take a look at number 8. Excuse me. Okay. Whoa, this is just a bunch of angles. Well, let's start with the single arch. Now the single arch is on letter S. Letter S can be just angle S, and it matches with angle E. Take a moment and see, can you write the 3 letters that can represent each angle, just to practice. For letter S, I can call it, or for angle S, I can call it HSQ or QSH. Sorry. And for the other side, we can call this angle FEQ or QEF, whichever way you'd like. Now let's do the doubles. Got a double here and a double there. Just like before, I can call it angle H and angle F because it's the only angle H and the only angle F that exists. However, I can use 3 letters. On the triangle on the left, I could have called it SHQ or QHS, and the angle F on the right, I could have called QFE or EFQ. Lastly, we have the triple angle that's in the middle. Now with these, we have no choice. We have to use 3 letters. The reason being, there are 2 possible angle Qs, and I need to be specific. For the triangle on the left, I will call this HQS. You can call it also SQH. For the triangle on the right, I'm going to call it angle EQF or FQE. Either way works as long as Q, which is the vertex, remains in the middle. All right, that's it for a little quiz review. Sorry, I'm going to cough again. If you have any questions, please let me know. Otherwise, have a wonderful, wonderful rest of your day. Bye!